Okay, welcome back. This time we'll be talking about section B, structured questions. Only 3 questions. Now, in this following 3 questions, I'll be pointing out the common misconceptions and mistakes most of you have made in particular questions. And you have seen the solution. It's pretty straightforward, but I really want to focus on the misconceptions. Now, the first one, it's something that you might know. Okay, so the setup is investigating the reducing powers of copper and silver. However, the student found that the reading on the voltmeter is 0. So first thing, do you know what is reducing power? Now, the reducing power means the ability to lose electrons. Okay, so if I have a stronger tendency to lose electron, that means I will have stronger reducing power. Okay, so in other words, you can also say the ability to reduce the metal. Okay, but for me, I think the best way for you to also understand is the ability to lose the electron, tendency to lose electron. So if it's higher, that means to have a stronger reducing power. So once you're able to understand this particular word, then the rest of the question should be a lot clearer. So explain why there is no electron flow in the external circuit. So that means they're saying that here there is no electron. Sorry, I should be going from this way. Why there is no electron movement? Very simple. One, let's look at the setup. It's a mixture of copper and silver nitrate, and they're all mixed together. And how will the copper lose electron and then this one gain electron? The answer is very simple. Copper, instead of the electrons moving from the external circuit, what exactly is happening is copper and then the silver nitrate. Which one is stronger in terms of electrochemical series? Copper. So that means silver will be displaced. So silver will start to displace over here. So therefore, displacement reaction will occur. Because the ions are transferred because of displacement reaction, therefore no electrons will be going outwards. Okay, this is very, very important, and many of you got it wrong. Even though some of you said that a build-up of charge, this time I have given you mark, but actually you shouldn't get any marks because there are no electrons flowing. So where will there be a build-up of charge, right? So this time I've given you mark, but make sure that the main reason here is because there's a silver ion and copper displacement reaction occurs. So the electrons are flowing between the ions and the metal rod. Draw a labeled diagram to set up the chemical cell. I was really surprised to see nearly 70% of you were not able to draw it accurately in terms of the setup. What I usually got was, I have 2 beakers, that is good. You're separating 2 mixtures and the 2 metal rod. And then let's say this one is Ag, silver, and this will become Ag nitrate. This one will be copper, and this will be copper nitrate. And other students usually made mistakes were some of you wrote this one is silver, and then this one you wrote copper nitrate. Well, how can it be possible? Where will be the electrons and the ions moving around? So therefore, you have to make sure it's matching. If I use silver metal, the solution I'll be using will be silver nitrate, vice versa for the copper. Now, the problem is, if I have this setup, how will now electrons will be going here and collected back. Now, is this a complete circuit? That is not a complete circuit. So I was really surprised that many of you forgot the fundamental stuff, which is the salt bridge. Well, the salt bridge has 2 functions. Number 1, it completes the circuit, and number 2, prevents the buildup of charges. And most of you did not add, so I only gave you 1 mark here, if you were able to draw the setup without the salt bridge. All right, number 2, which one has a stronger reducing power? Answer will be copper. We explained it in the beginning. Write the half equations at each electrode. Now the common mistake I saw was this. If you knew that copper is losing electrons, then you can get this correct. But many of you thought that silver is losing electron, which was weird because silver is lower at the electrochemical series. So copper, metal, loses electron to form ion, and then silver ion gets the electron and to form silver metal. Now what is missing in this answer? For those students who wrote like this, I just give you maximum 1 mark. I don't even know which electrode is it taking place in. So you have to write down, okay, this one is happening at copper electrode, and this one is happening in silver electrode. Some of you wrote anode cathode, that is also acceptable, but you have to specify. I realize many of you don't read the questions carefully, and hence you lose the marks even though it makes sense. All right, next question, 19. Another setup, this time with Saltbridge. So I was really surprised. I was giving you the answer already on the next page, and many of you did not see that. Now, with the aid of chemical equation, explain why is it not appropriate to prepare Saltbridge by soaking a strip of filter paper with potassium chloride solution. So now we are using potassium chloride if we use, and it's not appropriate. Now let's see what ions are contained in this solution. So we have silver, we have nitrate, we have iron 2, and we have sulfate. So now we have to see how will these ions react with these anions and cations. So we have positive and negative. Now potassium will react with nitrate to form potassium nitrate. Is there a problem? No problem. Potassium with sulfate? No problem. Now what about chloride with silver ion? If you remember this particular reaction, silver plus chloride will form silver chloride, and this is solid, white precipitate. So that's the reason why we do not add, because chloride ions will be formed. So basically you have to write this equation, which is Ag positive plus Cl negative will form AgCl. And you explain that, okay, because the silver ion will react with chloride ion to form white precipitate, and therefore that's why it is not appropriate. And then they ask you, okay, how do you prepare a salt then? Okay, common answers I got was why not I use potassium sulfate, and then I even saw potassium hydroxide. So why these two were not acceptable? Because iron oxide is a precipitate and silver sulfate is also a precipitate. So that's why you have to know these exceptions. We don't use sulfate and hydroxide a lot. So the only option will be potassium nitrate, which is the best. Direction of the flow from iron to silver. With the aid of half equations, state and explain the observable change at the iron-iron ion half cell. So over here we want to see what is happening. So we know that there's iron 2. Iron 2 is what color? Essentially it is yellow. Okay, my bad, green. So pale green. So iron 2 is pale green. So what is happening is iron will form into iron 2 plus electron. I realize some of you wrote iron 2 will become iron 3. Well, how can it form how can it be oxidized? Right? There's no oxidation happening here. It's just a transfer of electrons from iron to iron 2. So now we realize that iron is losing electrons and there are higher concentration of iron 2. So that means the color pale green will become more intense. And that's the reason, what's the observable change over here. All right, because there's a high concentration of iron 2 formed, therefore the solution become more intense. That's why you get 3 marks. So 1 mark for the equation, 1 mark for saying increase in concentration, and 1 mark for more intense. All right, last question, which is also the most important in a way that it is something unorthodox. You have not seen these questions a lot. And a very typical DSE styled question where to throw off students on how to solve this question. But if you look deeply, it is actually quite straightforward if you're able to get through the different ways. So we have a chromium can, the outer shell, a carbon rod, chlorine bleach this time to make chemical cell. When a cell is producing a current, the chromium can undergo oxidation. So that means chromium, the metal, is losing electron, right? Oxidation. So that means lose of electron to give this particular thing. While the carbon rod at the hypochlorite ions undergo reduction. That means gain of electron to give in the presence of water to give out chloride ions and hydroxide ions. So basically all the information is given. You have to just translate the words into equations. So let's look at the first one. Oxidation number of chlorine. So I let it be x equal to -1. Why is it -1? Because the charge is -1. So I just solve it. So x is equals to -1 plus 2 and x is equals to 1. Now if you were one of the students who put this one, I will give you 0 mark. Oxidation number must always have the sign, which means either positive or negative. If you write nothing, how would I know if it's negative or positive? This is no longer math. In math, we say 1 is positive 1, but here you have to specify plus 1. Question B. Given that the chlorine bleach is alkaline, write half ionic equation. Now this is actually the most crucial. Now the actual question did not have OH negative. I added by myself. So that means your equation must contain OH negative, not H positive. So we're looking at chromium metal. So let's look at what happened to chromium metal. Chromium metal can undergo oxidation to give out this particular thing. So I will know that, okay, chromium solid will form into this hexahydroxochromate 3. So I just have to write this down. 6, 3, negative. Now, is this balanced? We have chromium, we have chromium. How many hydroxide do I have? 6. So I have to add hydroxide over here. Negative 6. And then now I've balanced the hydroxide ions, I have balanced the chromium. Now I balance the charge. We have 6 negative, and we have -3. So where will I add the electron? Positive, plus 3 electrons on the right side. Does it make sense though? Yes, because the question said it undergoes oxidation, which means it loses of electron. And is it losing electron? Yes. So that's how you build up equation. Next one, reduction of hypochlorite ion. Hypochlorite ion is OCl negative. So I write it down, OCl negative. What does it give out? In the presence of water, so that means I add water, it gives out chloride ion and hydroxide ion. So I just write down chloride ion and hydroxide ion. That's it. Now I just have to balance the equation. So I have 2 hydrogen here, I have 1, so I'll add 2 over here. Is it balanced? Oxygen. There's 2 oxygen here, 2 oxygen over here, 1 chloride, 1 chloride. We're done. Now we balance the charge. Here is -1. Here is -1 and 2 negative. So that means -3. So where do we add the electrons? On the left, and 2 of them. Does that make sense? Reduction. Lose of a gain of electron. Is it gaining electron? Yes. Identify the flow of the electron. So where is the electron coming from? It's losing at the chromium and gaining by the solution. So the flow will be from chromium can to the carbon rod. Now the student noticed that the current is produced by cell increases the concentration of hypochlorite ion. Suggest a reason. So the electrical conductivity essentially increases with the concentration of hypochlorite ion. That's it. So the reason why it's increasing, it's because the increase in hypochlorite ion. We are producing more. All right. Now another question of this one. So we have a dropper, we have dilute hydrochloric acid, chlorine bleach, and we have a filter paper with potassium iodide. I'm just asking you to translate this one into this. So really easy. Sodium is Na, hypochlorite, OCl negative. So OCl negative, sodium is Na positive. So become OCl negative. OCl. There won't be negative over here. And then plus HCl to form chlorine with chlorine gas, sodium hydroxide, sodium chloride, and water. Many of you stopped here. You have to balance the equation. 2 chlorine over here. Hydrogen 2, so I have to add 2 over here. So 2, 1, and 3, balance. Remember to write the states. Next one, state the observable change. Whether or not the change would involve a redox reaction. Now, what happens is that chlorine gas is given, and that when sodium hypochlorite is reacted with hydrochloric acid, chlorine is given out. Now, the chlorine will react with iodide. So iodide will become iodine. Oops. Iodine will become iodide. Now iodide is brown color. So therefore iodide becomes iodine. So the filter paper turns brown, and then obviously it's a redox reaction, and the gas, so the chlorine gas oxidizes the iodide ion to form iodine. That's why it's like that. Okay? So that's pretty much it. The overall performance was okay, a bit lower than expected, but I hope you will learn from all these type of questions. You will notice that the first 2 questions were really basic. I did not really ask you too much in detail the theory. It was just basic understanding, and I realize many of you have not paid attention or revised a lot. And question 20 was testing you, how well do you apply if you're given a scenario where you've never seen, but you just have to read the question. That's it. So I hope the video is proving you useful. I hope you will be playing it back from time to time to revise this particular test, and hope to see you improve. Okay, so we'll stop here. Bye bye.